We're continuing to work through these midterm exam review problems for this class, Math 201, Brief Calculus. We are now ready for problem, let me find it. All right, hang on. I need to share this with you all. It's problem 49. Here we go. Sorry about that. So problem 49, we've actually done this before in terms of finding the equation of the tangent line. It's just now I think the function's going to be a little more complicated. I'm going to write down the information on this, then we'll work it. So this is 49. So the function or the equation is y equals negative 6x over x squared plus 1. And we're looking for the tangent line. Oh, actually, it's action for 2. Look at it. It says, find the equation of the tangent line for the graph at the origin and at the point 1, negative 3. So really, we're going to find 2 tangent lines. The first one at 0, 0. And the second one at 1, negative 3. So once again, we've done this before. The steps are where you're going to use the point slope equation, where if you have a point on the line and you know the slope of the line, you plug it in there and you can get the equation of the line. So for both of these, we're going to have to use the derivative of the function, because the derivative of the function is how we're going to find the slope of our tangent line. Because we're going to find, once again, the slope of the function at each of these points, and the slope at each of these points is going to be the same as the slope of our tangent lines. So this, I'm going to have to use the quotient rule. So low d high minus high d low over the low squared. Let me go ahead and multiply out the top, try and simplify a little bit. So these first two parentheses, I'd have negative 6x squared minus 6. Don't forget the minus here. So negative 6x times 2x is negative 12x squared plus 12x squared all over x squared plus 1 quantity squared. If I combine like terms, I can combine negative 6x squared plus 12x squared. 6x squared minus 6 over x squared plus 1 squared. So that's the first derivative. That's the derivative. So let's do the point at the origin. So what I want to do is I want to find the derivative, which is going to be the slope at this point when x is 0. So I plug in 0 for x, 6 times 0 squared minus 6 over 0 squared plus 1 quantity squared. This is 0. It looks like negative 6 over 1. So that is going to be the slope my point is 0, 0. So y minus 0 equals negative 6, x minus 0. Now I'm going to go ahead and see if that's correct, because that's all based upon this first derivative, and I don't want to do the second point if I've made a mistake. So let me go back. Y equals negative 6x all right, that's good. So now let me go back and we'll do it for the second point. 1, negative 3. So now I need to get the slope when x is 1. So I need to take my first derivative now and plug in x equals 1. So here's that first derivative, 6 times 1 squared minus 6 over 1 squared plus 1 squared. So 6 minus 6 over 2 squared looks like the slope is 0. What kind of line do you have when the slope is 0? That means you have a horizontal line. And the equation of a horizontal line is just simply the value of y. I know the value of y is negative 3. So the tangent line for that second point should be y equals negative 3. All right, that's good. So that was actually a problem we've done before. Looks like some kind of a story problem. Number 50, the temperature of T of a person during an illness is given by this equation where T is the temperature in degrees Fahrenheit and T is in hours, small t. So large T, capital T is the temperature of the person. Small t is the number of hours that have passed. And then there's 3 questions. Find the rate of change of the temperature with respect to time. Find the temperature at 1 hour. Find the rate of change in the temperature at 1 hour. So just so you know, sometimes these are called rate problems. Anytime they mention rate, if you see something about rate, that almost always is a clue that it's going to be the derivative. Derivatives, in a sense, are rates, especially when you're involved with time. If you have an equation with time and they ask something about the rate is going to be the derivative. So I'm going to write down this equation. So it looks like in part A, find the rate of change. And we're going to take the derivative of this large T with respect to small t. The second part, we're actually just going to find the temperature at 1 hour. So we're going to plug 1 in for T and find the temperature. And then the rate of change at 1 hour. So we've got 2 things going on here. Here's the equation for the person's temperature. But they also want to know how the temperature is changing with respect to time. So let me write this down, and as we work through it, if you don't quite understand what I'm saying, hopefully it'll become clear as we begin to work this problem. So this is number 50. You have this equation for the person's temperature as a function of time is 5t over t squared plus 1 plus 98.6. And A says find the rate of change of the temperature with respect to time. I'm going to write here what we're really going to find You'll see in a minute, d large T dt equals what? Part B, find the temperature when the time is 1 hour. And then C, the rate of change of the temperature at 1 hour. So let me show you what I've written down. I've sort of interpreted it. So here's an equation that tells you the temperature of a person according to how much time has passed. For instance, what's the person's temperature when the time is 0? You put a 0 in for small t, a 0 in for small t. This whole thing is actually 0, and it's 98.6, which is normally the temperature of a person in normal health. So there's two things going on. This is the equation that gives you the temperature of the person according to how much time has passed. However, they also want to know how the temperature is changing, the rate of change of the temperature. So it's not enough. Maybe the person's temperature is 101, but the question is the temperature going up or is it coming down? If it's coming down, then that means maybe they're getting better. But if it's going up, that means they're maybe not doing well. The temperature keeps rising. So it's like not just enough sometimes to know the temperature. You want to know how the temperature is changing. So that's what we're doing here. We're looking at two things, the actual temperature and how the temperature is changing. So part A, they're asking for the rate of change of the temperature. So we're going to take the derivative of this equation, and our variable is small t. So we got two terms here. First of all, the derivative of a constant is just 0. So really it comes down to the derivative of this first term, and I'm going to have to use the quotient rule because I've got a fraction here. So low d high, derivative of 5t is just 5, minus high d low, the derivative of t squared plus 1 is just 2t, over the low squared. Now let's see if we can simplify. It looks like, let me just do it here to save room. This is going to be 5t squared plus 5 minus 10t squared. So it looks like it's going to be negative 5t squared plus 5 over t squared plus 1 squared. Make sure I didn't make any math errors. So low d high minus high d low, and this is 5t squared plus 5 minus 10t squared. So that leaves negative 5t squared plus 5 over that. I'm going to go ahead and go back and type that in. That's the first question. Because if I somehow messed up, then I don't want to keep working when I've made a mistake. So we're saying the derivative is going to be negative 5t squared plus 5 over t squared plus 1 quantity squared. All right, that's good. So let's go back and keep working. Now the next thing they say is, so what was the person's temperature after 1 hour? Now we're not doing anything with the derivative for the second part. We're going back to the equation that gives you the temperature of the person, and we're simply plugging in 1 for t. 5 times 1, 1 squared plus 1 plus 98.6. This is going to be 5 over 2. 5 over 2 is 2.5 plus 98.6. That looks like 101.1. I'm going to go and enter that in a minute. Let's go and do this part. Now it says find the rate of change of the temperature when T is 1. In other words, I know the person has a high temperature, but at that time, after 1 hour, is their temperature going up or going down? Well, this will tell us this is the rate of change. If this rate of change is a positive number, that means the temperature is still going up. If the rate of change is a negative number, it means the temperature is going down. So now I use the derivative, which is right here, and I plug in 1 for T in this derivative equation. So -5 times 1 squared plus 5 over 1 squared plus 1. So -5 times 1 squared is -5 plus 5 is actually 0 over 2 squared. So you know what it says actually after 1 hour? It's like the temperature is not changing. So maybe it's leveled off. And then maybe, hopefully, as you wait some more, the temperature will start going down. So it looks like we could say maybe this is the maximum temperature, because probably the rate of change was positive. Now it's 0, and maybe the rate of change will turn negative. So let's go and enter these answers and see if they're correct. So I said at 1 hour, temperature was 101.1. And then we said the rate of change after 1 hour was 0. So maybe the temperature has reached its maximum. All right. Now, pretty straightforward. This looks like doing some derivatives using the chain rule. Actually, maybe I can just talk through this one, right? The chain rule, outside, then inside, outside, you bring the 5 down front. You copy. Oh, I better do it. I could do it in my head, but in case anyone isn't sure about what I'm doing. So y equals, you know what I might do actually? There's a chance I might have a few of these in a row. Yeah, maybe I'll write all these down in a row and just do them all. So 52 is y equals square root of x squared plus 9. See what the next problem is. That's another, I think, chain rule problem. 53, y equals 3x squared minus 9 raised to the -11th power. Let's see, keep checking until we run out. Here's actually another chain rule one. Y equals 1 over 5x minus 16 raised to the 4th power. I wonder if we're about out. Yeah, this is chain rule, but with the product rule. So, all right, so I'm going to go back to that first one. And I'm going to work all these out, and then we'll come enter the answers and see, hopefully. So 51 was the first one. Chain rule is when you have normally stuff inside parentheses and the parentheses raised to an exponent. We have to use the chain rule to take the derivative. The chain rule, that is, you take the derivative, what I call the outside, you sort of ignore what's inside the parentheses. You just think of it as like a black box. You simply copy down what's inside the parentheses. You subtract 1 from your exponent. Then you multiply by the derivative of what's inside the parentheses. Derivative of 3x minus 2 is just 3. So we should end up with 15 times 3x minus 2 raised to the 4th power. So we'll enter that in a few minutes. Hopefully that'll be correct. Now this one, I don't see any parentheses, but remember now, usually in math, oftentimes when you're doing math, we don't necessarily work with radicals. Oftentimes we will change, in this case, a square root is the same thing as an exponent of 1/2. When I do like this, then I can see that I can apply the chain rule and take the first derivative. Once again, the outside, you bring the 1/2 down, you copy down what's inside the parentheses, then you subtract 1 from the exponent, so 1/2 minus 1 is a negative 1/2. And then you have to multiply by what's inside the parentheses, which would be 2x. So 2x times 1/2 just leaves x. Since this is a negative exponent, this thing goes in the bottom, and I don't know if it matters. I'm going to just switch it to a radical because it's going to be x squared plus 9 to the 1/2. I'm sure my math lab will probably take either one. The third one of these 4 chain rule problems, pretty straightforward. We have parentheses raised to an exponent. Even though it's a negative exponent, we still just apply the chain rule. Outside, bring the exponent down, copy down what's inside the parentheses, subtract 1 from the exponent. So negative 11 minus 1 is negative 12. Then you multiply by the derivative of what's inside the parenthesis, 6x. So it looks like negative 66x. And I assume they probably want a positive exponent, so I'll stick that in the bottom. And then the last one, I guess you could do a quotient rule here, but I'd rather just move this to the top, make the exponent a -4, and then use the chain rule. So -4, copy down what's inside the parentheses, subtract 1, multiply by the derivative of what's inside the parentheses, which is just 5. So it's like negative 20 over 5x minus 16 to the 5th power. So I'm going to go back and enter these answers and see if we are correct. So this first one was 15 times 3x minus 2, 15 times 3x minus 2 raised to the 4th power. All right, that's good. The next one we did was x over, I'm going to go ahead and put a square root here, x squared plus 9. All right, 2 for 2. This next one was negative 66x divided by 3x squared minus 9, all that raised to the 12th power. All right, 3 for 3. Let's see if we can finish it off. This last one was negative 20 over 5x minus 16 raised to the 5th power. All right. It's my lucky day. They're all correct. All right. I'm going to stop now. The next video we'll pick this up. Looks like it's going to be a combined product rule and chain rule at the same time. So we will work on that in the next video.